we're going to do a Newman projection of 2,2-dimethylbutane, but I have to do it looking down on carbons 2 and 3 right here. So carbons 2 and 3 are going to be represented by the circle of the Newman projection. And what I like to do is actually I circle them so that I don't get lost in here. Again, I'm going to represent these two carbons right here by the circle. So let's go ahead and do the circle. And they don't actually say anything about staggered or eclipse, but they do say the most stable. So automatically, I know that the most stable conformation is going to be a staggered conformation. So I'm going to put my lines staggered right here. Remember that whatever is attached to the front carbon, those substituents start in the middle of the circle. The substituents attached to the back carbon are on the lines that start on the very edge of the circle. So now I go to my structure right here. Either one of them can be the front carbon. I'm just going to make the one on the left be the right carbon, and that carbon has 3 methyls attached to it. So I'm going to go to my Newman projection, and I'm going to attach 3 methyls on the front carbon. This one right here, carbon number 3, would be the back carbon, and there's 2 hydrogens and 1 methyl attached to the back carbon. Right now, go wherever you want to put them. I'm going to put the methyl here, a hydrogen here, and the other hydrogen down here. So this is a staggered conformation. I do not know if that's going to be the most stable or not, so I'm going to do the whole process here. And what I'm going to do is rotate one of the carbons. It doesn't matter which one you rotate. I tend to rotate the back carbon, but notice that the Newmans that I'm doing, they don't actually change. I'm still in the staggered conformation because I know the staggered is going to be the most stable. So I'm going to just leave the front carbon intact. I'm not going to move the front carbon. I'm going to move the back carbon, and I want to go from one staggered to the next. So what I'm going to be looking at is where this methyl is. Right here is on the right. I'm going to move it until it comes down here to the bottom. So this is a rotation of 120 degrees. And then I rotate 120 more. And the methyl comes to the left side. Now, if you notice, I have 2 gauge interactions, one here and one here. I have 3 methyls right next to each other. In this staggered conformation, I also have 3 methyls right next to each other. And in the last one, I also have, again, the 3 methyls right next to each other. So these 3 staggered conformations, they all have the same amount of energy. So that's what we're going to call degenerate Newman projections. They all have the same energy. So whichever one you pick, that's going to be the most stable because there's no other more stable Newman conformation.